Right, so far you have read about driver gears and driven gears. An idle gear is another important gear. In the example, gear A turns in a counterclockwise direction, and also gear C turns in a counterclockwise direction. The idle gear is used so the rotation of the two important gears is the same. The example below is a gear train. Next, we will examine how to find the gear ratio for a gear train that has more than two gears. When the number of shafts in a gear train is odd, the first gear and the last gear are going to rotate in the same direction. When the number of shafts is even, the gears rotate in an opposite direction. Just a little FYI information for you to know. Okay, so let's kind of talk about whenever we have a longer gear train. Right? We're going to look at these as kind of like compound machines, right? Because we have one gear to the next. So my torque out would equal my gear ratio times torque in, just like force out was equal to mechanical advantage times force in. In this, though, we need to see that our gear ratio total is each ratio multiplied together, and we're going to use that in the next in the next slide. So here I have a longer gear train. Right? I have A to B, and then B to C, and C to D. Okay, so we're still gear ratio. We only have the number of teeth, so we're going to use that. Number of teeth over number of teeth out divided by number of teeth in. Okay? All right, so gear A driving B is going to be out over in. So we have 12 divided by 20. Okay, then we have B to C, just like we talked about in the one before. We're going to multiply these together. So B to C is 5 divided by 12, because now 5 is our out and 12 is our in. Right, times the next one, which is C to D. So we have D is our out, 5 is our in. Okay, which equals a 1-to-1. And notice that every single time the gears B here, or A, okay, let's look at this. B is the one on top. Again, B is on bottom. It's always going to cancel out. C here is on top, and it's on bottom again. It's always going to cancel out. So really, all we have to do whenever we have a longer gear train is look at the gear ratio of the first one and the last one, because the others will always cancel out. Right? So if gear A and D were directly connected to each other, the result is going to be the same. All right, so what would the gear ratio be if the last gear was 40? Like I said, B and C we can ignore because each time they cancel out. So we would just have 40 over 20, which is a gear ratio of 2. So compound gear train. Compound gears are used in engines, workshop machines, and in many other mechanical devices. In the diagram, gear A is actually 2 gears attached to each other, and they rotate around the same center, so the blue and green gears rotate at the same angular velocity. Sometimes compound gears are used so that the final gear in a gear train rotates at the correct speed. Right, so let's talk a little bit more about that. In this compound gear train, notice the dark purple gear is going to turn twice the rate of the blue one. Even though these are the same size, they are going to rotate at different speeds because it is meshed with the smaller one. They're sharing a shaft. So this one is going to turn faster, making the one on bottom turn faster. And if it was twice the size, we're looking at twice as fast. All right, so going a little bit farther, the purple gear turns twice the rate of the blue gear. The green gear turns at twice the rate of the purple gear. And the red gear turns at twice the rate of the green gear. All right, so this is how we can speed up our the last gear. That's how we can speed it up, is by using these compound gear trains. If we're wanting to increase our torque, though, we would not want to increase the speed. Instead, we would maybe use a smaller one going to a bigger one to try to decrease the speed if we're wanting to increase our torque. Okay, again, if we're still trying to speed it up, notice the large gear is 5 times the size of the smaller gear. Right? The purple gear is driven at 100 RPMs. The gear ratio to green gear is 1 to 5. Okay, so the angular velocity for the green gear is 500 RPMs. The green gear is driven at 500 RPMs now. So the gear ratio to the red gear is 1/5. So our angular velocity for our red gear is 2,500 RPMs. So it's going to speed it up by a huge amount. Again, the faster it goes, though, my torque is going to be less. But the middle, on this example, the two middle gears share a common axle, so they rotate at the same speed. This allows the final gear to rotate slower and produce more torque than if it were connected only to the driver gear. Again, notice how we're going from a large gear to a smaller one, and a large to small. All right, so this says it allows the final gear to rotate slower. I keep doing that. For some reason, these examples like to go from right to left. So we're saying that the green one is our driver gear. It's going from a small one to a larger one. And that's why it's going so much slower. And it's going to then increase our torque. Okay, so we're going to examine this a little more. What is the gear ratio? Right, well, I need a gear ratio from A to B, and I need a gear ratio from C to D. Like the compound machines, I need to then multiply those two together to get my final gear ratio. Again, in out over in. All right, so my out is 40, my in is 10, so it's a gear ratio of 4 for A to B. Then I need my C to D. It goes from 20 to 50, so 50 divided by 20 is 2.5. Now I need to multiply those two together. So 2.5 times 4 equals 10. So my total gear ratio for this compound gear is 10. Okay, so drawing gears. It would be very difficult to draw gears if you had to draw all the teeth every time you wanted to design a gear system. For this reason, a gear can be represented by drawing two circles. You'll see me use that in some of the problems. Mine might not be perfect circles, but I get that done. A pulley system are used when there is a need to transmit rotary motion. The diagram below shows a simple system comprised of two pulley wheels and a belt. It is a simple mechanical device to winch up and down a rope. When the motor is turned on, it revolves the driver pulley wheel. The belt causes the driven pulley wheel to rotate as well, winding out the rope. All right, so pulley wheels are grooved so that the belt cannot slip off. Also, the belt is pulled tight between the two pulley wheels in tension. The friction caused by this means that when the driver rotates, the driven follows. We're looking at the same equations. All right, this diameter out over diameter in equals angular velocity in over angular velocity out, which equals torque out over torque in. Of course, we don't have teeth on this one, so we're not going to see number of teeth. But it's worked the exact same way. Okay, all of these equaling the gear ratio or pulley and belt system ratio would be 3. Nice bucket and train system. Everyone has seen a bicycle or used one and noticed that it is driven by a large driver gear wheel that pedals attached. Smaller gears at the back are given round. Smaller gears at the back are driven round, in turn driving round the back wheel. As the back wheel turns, the bicycle moves forward. Gears driven by the chains are used in machinery, motorcycles, car engines, and many more applications. And so a chain is made up of a series of links that the links held together with steel pins. This makes a chain a strong, long-lasting way of transmitting rotary motion from one gear wheel to another. Chain drive has one main advantage over a traditional gear train. Only 2 gear wheels and a chain are needed to transmit rotary motion over a distance. With a traditional gear train, many gears must be arranged, meshing with each other in order to transmit motion. Okay, again, equations are the same as the gear. We have the number of teeth on this one as well because we have teeth on the sprocket and chain system. All right, so again, our ratio is 2. All right, so let's compare them a little bit. A pulley has a belt, a sprocket has a chain. Right, the advantages of a pulley is it's quiet, no lubrication needed, it's inexpensive. A sprocket has no slip, it's a greater strength. It also is going to have a better torque because it gets into the chains and it's going to have a better torque than the pulley. The disadvantages, the pulley can slip. The sprockets cost a little bit more, they need lubrication, and they are noisy. Okay, I'm going to work problems in the problem videos, which you can watch next.